Welcome to The Explainer. With trust in our institutions feeling like it's at an all-time low, there's one massive question that keeps coming up. How do we actually protect the very foundation of democracy, our elections? Today, we're going to look at a pretty radical answer.
Okay, so let's just dive right in with the big one. This is probably one of the most pressing questions in any modern democracy. And frankly, it can feel kind of unsolvable, right? Like every time we come up with a solution, it just creates a whole new set of problems. But what if we've been looking at this all wrong? What if the solution isn't about finding more trustworthy people or writing stricter rules? What if we could build a system where you don't have to trust anyone at all? Yeah, seriously. It's about taking trust completely out of the equation.
The key is this idea of an unhackable public notebook. The technology behind it is called a blockchain. Now I know, the name sounds super technical, maybe a little intimidating, but the core idea is actually wonderfully simple.
Just think of it like this. It's a public record book that's basically tamper-proof because everyone has a copy. Imagine you and thousands of other people all have the exact same spreadsheet on your computers. If one person tries to secretly change a number on their copy, what happens? Instantly, their version doesn't match everyone else's, and the system just rejects it. It's security through mass agreement, all locked down by pure mathematics.
So there are really three key things that make this all work. First, it's distributed. That just means there's no single server to attack, no single point of failure. The ledger is everywhere at once. Second, it's immutable. Once a vote is cast, it's permanent. It's set in stone and cannot be altered. And third, it's transparent. Anyone, and I mean anyone, can audit the entire voting record. These three features together basically solve the biggest weaknesses of our traditional, centralized election systems.
Okay, but wait, how do all of those thousands of computers agree on what's true? Well, this is where the real genius comes in. It's a security model that makes lying incredibly expensive and time-consuming. It's called proof of work.
So here's the deal with proof of work. Every new page of votes added to this notebook is the result of a worldwide competition to solve a really difficult math problem. So to change even one little vote in the past, an attacker doesn't just hack a server. No way. They have to resolve all the math problems for every single page since then, and do it faster than the entire global network. It's a hack. It's basically a declaration of war against a global system.
So let's put some actual numbers to this, because this is where it gets really wild. What would it actually take for an attacker to pull this off in, say, a national election? As you're about to see, the resources you'd need are just astronomical.
To even have a shot, an attacker needs to grab control of more than half of the entire network's computing power. To do that, they'd need an army of specialized computers. We're talking about roughly 464 of the most powerful machines built for this kind of work, called ASICs, which solve these math problems at blinding speeds.
The hardware alone, that would cost you over $1 million, and that's just to get in the door. That's before you've paid for a warehouse to put them in, the industrial-scale cooling to keep them from melting, and of course, the massive power bill that's on its way.
And that power bill, yeah, we're talking over $4,000 every single day. You are literally fighting the honest network by burning colossal amounts of electricity.
And here's the most brilliant part of the whole thing. While our attacker is spending millions trying to rewrite the past, the honest network just keeps on working. It adds new, valid blocks every 60 seconds. The finish line is constantly moving away from them, making their impossible job even harder with every single minute that passes.
This changes the entire game. The security model isn't based on making it illegal to cheat, it's based on making it a completely irrational, awful financial decision. I mean, why would anyone spend millions on an attack that is almost guaranteed to fail?
So, what does all of this really mean for democracy? Well, it's a fundamental shift in how we even think about security. It's about moving away from a system based on trust and toward a brand new one based on proof.
We're talking about shifting from a fragile system that relies on us trusting people in hidden databases to a resilient one that relies on verifiable mathematics. Instead of being told the results are correct, you can check the math yourself. The entire process from start to finish is open for anyone to see.
And this is why the system doesn't need to rely on trusting any administrators. The rules are just baked into the code itself. That immense cost from proof of work, that's what stops people from creating fake voters. It makes voting twice mathematically impossible. And because it's a public ledger, it prevents any silent manipulation of the vote count and kills the risk of hidden database edits. Integrity isn't a policy that can be broken. It's just a fundamental property of the system.
And that's really the key takeaway here.
In a world full of deepfakes and misinformation, this offers a foundation for truth that isn't based on who you believe, but on what you can actually verify. The integrity of an election is guaranteed not by promises, but by the fundamental laws of math and the economic realities of energy itself.
So, okay, this system secures the vote, but what about the voter? How can you prove you're a unique, eligible citizen without creating a massive surveillance database? Join us for our next explainer, where we'll explore how this very same technology might just solve the problem of digital identity.